Okay, number 45. Oh, look at all those directions. Write the polynomial A as a product of factors that are irreducible over the rationals. So that means we got to factor completely. B as the product of linear and quadratic factors that are irreducible over the reals. What? That means completely factor also. And C in completely factor form. What? And that is like 3 different ways we can write our answer. All right, so let's just get busy with it. Let's just completely factor it and see if we can write our answer like all of these are asking us to. The first thing we're going to do is we're going to divide this nasty thing by this nasty thing. Yes, that's right. That trinomial is nasty. He is not factorable, so I'm going to call him nasty. Oh, you nasty. All right, let's hope I can fit everything in here, yeah? Probably not. Let's write a little bit smaller. X squared, no, to the 4th. Okay, so you're like trying to say that you will only give me candy if I give you a good grade. X to the 4th divided by x squared. What's that? It is x squared. Okay, so if I go x squared times that, x squared times that, x squared times that, I get x to the 4th minus 2x to the 3rd. Minus 2x squared. Woohoo! I'm changing all the signs. I add them together. These guys get canceled out. This one becomes a negative 2x to the 3rd. And then we have a 7x squared. And then I bring down my next term, negative 2x. All right, we got 3 terms here. Yes, we do. All right, so let's keep going. What is that first term divided by that first term? That would be negative 2x to the 3rd divided by x squared. That will be negative 2x. And so now I got to multiply that to that guy, and that guy. And what do I get? I get, wait, is that negative? Yeah, negative 2x to the 3rd. And then I have a positive 4x squared. And then there's a positive 4x. All right, change of signs because I'm subtracting. And I don't like messing up with my negatives. Those add to 0 so I can cross them out. Crossing things out makes me feel good because it means I probably have less work to do. And then I have negative 6x, and I bring down the last term, which is negative 6. Oh, daggity waggity. All right, so it looks like if I take this first term divided by x squared, I get a 3. So I'm going to go plus 3. And everything should work out really prettily and nicely. So you have 3x squared, negative 6x, and then negative 6. It looks like those are exactly the same, so we know that we're going to subtract those and get a 0. So I have that as what's left over of this when I factor or when I divide that out. So that means we have x squared minus 2x minus 2 times x squared minus 2x plus 3. Oh, dang, that was a lot of work. This is what I got in factored form so far. This times this would give me f of x. Okay, we know that one's not factorable because I can't find anything that multiplies to give me negative 2 and then adds to give me negative 2. But is there anything that multiplies to give you 3 but then adds to give you negative 2? Is there? No, it is not factorable. We can't factor this guy either. Oh, sad times. Everybody said, oh. Okay, so what we're going to have to do, if we want to find the zeros for these, we have to use a quadratic formula. There's not like a cubic formula, so don't worry. If you get cubics, you won't get any cubics. But if you have quadratics, we can use the quadratic formula to find our zeros. So let's do the first one. For the first one, we have our negative b. So we have negative 2 plus or minus the square root. B squared, which is going to be 4, minus 4 times a times c, which is negative 2. And then we're dividing that all by 2 times a, which is just 1, so it's 2. So this is going to be a positive 2. We have plus or minus. Let's go partying here. We have a negative 4 times 1 times negative 2. It'll be a positive 8, so it's 4 plus 8. And that will be a 12. So we have the square root of 12. So we have 2 plus or minus 2 square root of 3 divided by 2. What? Where did 2 square root of 3 come from? I can split this square root of 12 up into the square root of 4 times the square root of 3, right? Right. And I chose 4 and 3 because 4 is a perfect square. What is the square root of 4? Dos. So I could actually simplify this even more. I could divide this by 2 and that by 2. And so I get 1 plus or minus the square root of 3. So I got 2 zeros right here. I have a 1 plus red 3. And I have a 1 minus red 3. Hey, look, conjugal pair. Yeah. We got to do that one more time. We got to do another quadratic formula for this guy. So we got negative 2 because it's a negative b. And then we go plus or minus, woo. And then we have negative 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 3. Notice how I'm not trying to do everything in my head. Yes, I am teaching, but at the same time, when you're doing too many steps in your head, you make mistakes, so don't do it. Then on the bottom, we have 2 times a. A is 1. And then we got to simplify. So we get a positive 2, plus or minus. Let's go to the party over here. We have negative 4 times, is that negative 4 times 3? Oh, I see what's going to happen here. We have 4 minus 12. 4 minus 12 is going to give me a negativo, so I get a negative 8. Ew. Negative means there's an I, so we can get rid of this negative and put an I right here. I means square root of negative 1. And then I can split this up. Actually, here. I can split the 8 up into the square root of 4 times the square root of 2 times the square root of negative 1. This is your I. Square root of 2 stays, and this one becomes a 2. So now we can rewrite this as 2 plus or minus 2 square root of 2i divided by 2. Hey, it's divided by 2. That means we get 1 plus or minus the square root of 2i. I like to put this little hangy thing there to note that we are not including the I in the square root. Put that dude up there. Then we have 1 plus square root of 2i, and then 1 minus times the square root of 2i. Now we got all our zeros. Yay! Okay, so this says, write as a product of factors that are irreducible over the rationals. Over the rationals. You guys got that? That is this guy right here. It's not reducible. We can't reduce this anymore over the rationals, so this is part A. We did it. Yay. Okay, let's see part B. As a product of linear and quadratic factors. Oh, that is also that. And then we have over the reals. So this one satisfies the A and the B. Mm-hmm. And then we have the last one in completely factored form. How do we do that? We got to use our zeros. All right, so this is how we do it. We got x minus 1 plus square root of 3. X minus 1 minus square root of 3. And then we have x minus 1 plus square root of 2i. Oh man, no way, I ran out of space. I'll just put them on the other side. That's a good idea. Okay, and then we have x minus 1 minus square root of 2i. There you have it. There's the last answer. Would have had a different answer for B if one of these was factorable, I think. Yeah, because rationals, like this is not rational right here. Square root of 3 is irrational, and this is imaginary. Yeah, I'm trying to separate A and B here, but this problem I don't think you can.